Hello everyone, this is Mr. McMillan. I'm back here with another instructional video, this time on verifying and proving that lines are parallel. So previously we talked about the special angle pairs that were formed when a transversal line passes through two different lines. Today we are going to discuss how to prove and verify these lines are parallel. A blank copy of the notes of these are on Google Classroom, but also if you are hybrid, you've been sent home with a set of blank notes that you can follow along with. I would highly recommend following along, writing these things down, and also working out the example problems. This video will be mostly example problems after this initial page. So let's look at some theorems and postulates. The first theorem / postulate we're going to look at is the corresponding angles postulate. So the original statement for this is that if two parallel lines are cut by a transversal, then the pairs of corresponding angles are, and so we're talking about corresponding angles, and we know that corresponding angles should be congruent if the two lines are parallel. Now you're going to notice that I have the word converse written here. If you remember when we talked about logic, we wrote converses by switching the hypothesis and the conclusion, okay? So remember, the hypothesis comes after the word if and before the word then, and then the conclusion comes after the word then. So our converse would basically be if the pairs of corresponding angles are congruent, then two lines cut by a transversal are parallel. Okay, and for each one of these postulates and theorems, I'm going to show you what I mean in a diagram. Okay, so if we draw a diagram here, just wherever you have space, I'm going to draw a small one here. Let's say that we had two lines, A and B. Okay, so we've got an A out here, a B out here. And we want to prove these two lines are parallel. Basically what you're looking for, at least for the corresponding angles postulate, you're looking for congruent corresponding angles. Now to mark congruent angles, we take our pencil, pen, whatever, and we put your congruency marks here. It's just a little semicircle that goes in the corner of the angle. That signifies that they're congruent. Well, if this angle is congruent to something, it has to be congruent to this angle up here because these two are corresponding angles. And if the pairs of corresponding angles are congruent, then that implies that A is parallel to B. All right, let's look at the next one, the alternate interior angles theorem. Our original statement, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So our converse would be if the pairs of alternate interior angles are congruent, then two lines cut by a transversal are parallel. Again, we're going to draw a diagram to signify this. And again, we're going to use lines A and B here. Now this time we want the alternate interior angles to be congruent. So just pick a pair of the alternate interior angles. So for example, this one and this one. So if those are congruent, then this implies that A is parallel to B. you can see where this is going, right? Alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. That was our original statement. So the converse would be if the pairs of alternate exterior angles are congruent, then two lines cut by a transversal are parallel. So this time we're going to draw our diagram and we're going to identify two alternate exterior angles to prove that they're parallel. So for instance, if these two angles are parallel, or sorry, congruent, not parallel, that implies that A is parallel to B. Okay. Now let's look at the same side consecutive interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are, and we know that consecutive interior angles should be supplementary. So again, if the pairs of consecutive interior angles are supplementary, then two lines cut by a transversal are parallel. Okay, and so if we draw out our diagram here again, now this time we want the consecutive interior angles to be supplementary. Well, we can't really just make a mark on there. So what I'm going to do is I'm going to draw or write an X and a Y in place of those two angles. So if the measure of angle X plus the measure of angle Y is equal to 180 degrees, this implies that A is parallel to B. And then finally, same side consecutive exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of consecutive exterior angles are supplementary. So if the pairs of consecutive exterior angles are supplementary, then two lines cut by a transversal are parallel. And then our diagram here, got A and B, put X and Y here. So if the measure of angle X plus the measure of angle Y is equal to 180 degrees, and that means A is parallel to B. So basically it's the exact same thing we've been doing. This time we're just showing why they're parallel. Okay, so in some of these problems, all you're going to be doing is writing which ones are parallel and by which theorem. That's it. I do want to point something out though. You'll notice that we didn't talk about vertical angles or linear pairs here. There's a reason for that. Vertical angles and linear pairs cannot be used to prove two lines are parallel when cut by a transversal. However, note that two identical intersections indicate parallel lines as per the theorems above. So let's look at some example problems. We are going to look at 12 example problems. And you might be going, why are we looking at so many? I just want to make sure that everybody has a grasp on this. So number one, it says, based on the diagram, determine which lines are parallel. Justify your answer. When you see the words justify your answer, that means you are going to write your reason. You are going to write the theorem or postulate that you used. Okay? So let's look at our angles here. So we have angles that are congruent here. So the first thing we're going to do is see which lines these are attached to. Okay? So you can see that this side and this side are part of line A and line C. So we see that this angle is attached to lines A and C. And here we see this angle is also attached to line A, but it's attached to line D. So the angles are on lines A, C, and D. The next thing you want to do is identify which one of these is your transversal for the one you're talking about here. So A, C, or D, which one would be the transversal? Well, line A would be the transversal because it cuts C and D. So A is the transversal. So now we need to see if they have a particular relationship here. So what type of angles are these? Well, these are alternate interior angles. And we see on the diagram that it says that they are congruent. Are alternate interior angles supposed to be congruent? Yes, they are. So that means by the alternate, and you can just abbreviate it, alternate interior angle theorem, C is parallel to D. All right, number two. Number two says, based on the diagram, determine which lines are parallel and justify your answer. Again, same exact process as what we did here. We're looking for the congruency marks or whatever marks that we have for our angles. And we see that we have an angle here that's attached to line P and R. And then we have an angle here that's attached to line S and R. So our angles are on lines P, S, and R. And again, we have to identify which one of those three would be the transversal. Well, R cuts both P and S, so R is the transversal. So now what we need to do is we need to look at the relationship for these angles. Well, these two angles are congruent, and these two angles specifically are corresponding angles. They are supposed to be congruent. So by the corresponding angles postulate, P is parallel to S. Okay. You're never going to have your transversal be parallel to the lines that it cuts. Okay, so make sure you write them down correctly. Number three, based on the diagram, determine which lines are parallel. Justify your answer. So this time we have three angles instead. So we need to look at each one. Okay, so we're going to look at each pair of them. That would be reasonably considered to be part of an angle relationship. So let's look at these congruent angles, 96 and 96. We see, so the pair of 96s, we see they are attached to lines X and M as well as X and N. And we see, and if you look here, X cuts both M and N, so that means X is the transversal. So X is the transversal. Now, these are congruent angles. We have to see what type of angles they are. They are alternate exterior angles, which indeed should be congruent. So by the alternate exterior angles theorem, M is parallel to N. Now, 96 and 84 don't have, this 96 and this 84 don't have any type of angle relationship, right? But we do know that 96 and this 96 and the 84 do. And that 96 and 84 are attached to lines X, Y, and M. And if we look here, M cuts X and Y. So M is the transversal in this case. Well, these are consecutive exterior angles. And if we take 96 and add 84, we get 180, which means they are supplementary. Consecutive exterior angles should be supplementary. So by the consecutive exterior angles theorem, X is parallel to Y. So both sets of lines are parallel in this diagram. All right, number 4. If the measure of angle 7 plus the measure of angle 10 is equal to 180 degrees, determine which lines, if any, must be parallel. Justify your answer. So determine which lines, if any, must be parallel. So let's look at angles 7 and 10. So 7 is here, 10 is here. Well, 7 and 10 are attached to lines. We see 7 is attached to line X and A. And then 10 is attached to lines Y and A. So we have to see which one of those is the transversal. And we see that A cuts both X and Y, so that means that A is the transversal. Now we see that angles 7 and 10 are consecutive interior angles. And our problem says that they are supplementary. Well, are consecutive exterior or interior angles supposed to be supplementary? Yes. So by the consecutive interior angles theorem, X is parallel to Y. Now, there are some cases where you will not end up with a set of parallel lines. You just have to check and make sure, okay? Remember, if they're vertical or linear, they can't be used to prove it. So let's look at this one. If angle 2 is congruent to angle 16, determine which lines, if any, must be parallel. Justify your answer. So we're going to look at angles 2 and 16. Well, 2 is attached to M and L, and 16 is attached to M and K. So we have lines L, K, and M. And we see that M is our transversal. All right, M is the transversal. So we're looking at lines L and K. Now let's look at the relationship between 2 and 16. Well, 2 and 16 are alternate exterior angles. And our problem says that those are congruent. Are alternate exterior angles supposed to be congruent? Yes, they are. So by the alternate exterior angles theorem, L is parallel to K. All right, number 6. Number 6, lines R and S are cut by transversal T. Which of the following would prove that R is parallel to S? Okay, so we're going to have to look at each answer choice here. Okay, so answer choice A says angle 3 is congruent to angle 8. So angle 3 and angle 8 are consecutive exterior angles. Are consecutive exterior angles supposed to be congruent? No, they're supposed to be supplementary. So we know it can't be A. Let's look at B. Angle 4 plus angle 5 is equal to 180 degrees. Well, 4 and 5 are consecutive interior angles, excuse me. And are those supposed to sum to give you 180 degrees? Are they supplementary? Yes, consecutive exterior or interior angles are supposed to be supplementary. So we know this is our answer. But let's go and look at these just to see why these wouldn't be. So let's look at angle 5 and angle 7. Angle 5 and angle 7 are vertical angles. When you identify that something is a vertical angle pair, you can stop because that will not prove that R is parallel to S. Okay? Vertical angles are always congruent no matter what. So these are vertical, so they can't be used. And then here, D, measure of angle 1 plus the measure of angle 2 is equal to 180. Angle 1 and angle 2 are a linear pair. Full stop, you can stop. Linear pair, they can also not be used. So vertical angles and linear pairs cannot be used to prove lines are parallel. Number 7, lines C and D are cut by transversal K. Which of the following would prove that C is parallel to D? So in answer choice A, we have angle 4 is congruent to angle 2. Well, angle 4 and angle 2 are consecutive exterior angles, so they should be supplementary, not congruent. B, we have angles 8 and angle 7 being congruent here. Angles 8 and angle 7 are consecutive interior angles, so they should be supplementary, not congruent. Answer choice C, the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. We have angles 3 and angles 2 here. Those are alternate exterior angles. Alternate exterior angles are congruent, not supplementary. So D is our answer, but let's look at angle 5 and angle 7. It says they're congruent. Angle 5 and angle 7 are alternate interior angles. If they are alternate interior angles, then that means they should be congruent, so D is indeed correct. Number 8, which pair of angles must be supplementary in order for line S to be parallel to line T? Basically, you're looking to see if you have any consecutive interior angles or consecutive exterior angles in your thing. So, do you see ones that are consecutive interior or exterior in this problem? And you should be able to spot it real quick. Angles 2 and 5 are consecutive interior angles, and those must be supplementary for S to be parallel to line T. So your combination would be angle 2 and angle 5. That must be supplementary. Let's look at the next page here, the last page of the example problems. Number 9, lines R and S are cut by a transversal. For what value of X is R parallel to S? The first thing you need to do, pretty much in all of these problems, is you need to tell what type of angles they are, whether they should be congruent or supplementary, then go from there. Well, X and 102 degrees here, those are alternate exterior angles. And if you remember, alternate exterior angles are congruent, which means they are equal in measure. So X has to equal 102 for them to be parallel. Number 10, lines Y and Z are cut by a transversal. What value of X will show that line Y is parallel to line Z? Well, if we look at this, 7x plus 5 and 35 do not have a special angle relationship. But if these two lines are parallel, we know every obtuse angle is supplementary with every acute angle. So that means these two angles must be supplementary. So we know that 7x plus 5 plus 35 has to equal 180. Combine like terms and you get 7x plus 40 equal 180. Subtract 40 from both sides and you get 7x equals 140. Divide both sides by 7 and you get that x must be equal to 20 in order for them to be parallel. Number 11, transversal D cuts through lines W, X, Y, and Z, which is a true statement. And you're going to see which one of the following statements is true. Well, here we have 4 different intersections, okay? The easiest way to go about this is just determine all the angles in the intersections and see which match up exactly. So 94, we've got vertical here, and this will be a linear pair, 86. And I'm just running through these real quick, okay? 86, 94, 94, 82, 98, 98, 98, 82, 82. So which intersections match? The intersections that match, are W and X. So W is parallel to X. And Y and Z match up. So Y is parallel to Z. So that would be answer choice D. Number 12, our last one here. Line A is a transversal for lines E, F, G, and H, which is not parallel to the other 3. So just like last time we were seeing which ones matched up, this time we're looking for the one that does not match up. Okay, so let's look and see which one doesn't. So we're going to fill in our values here. So this would be 110, this would be 70, this would be 70, this would be 75, this would be 105, 105, 110, 70, 70, and 70, 110, 110. So which intersection does not match with the other 3? Well, G, E, and H all match, but F is the one that doesn't, and you can see it right here. So F, which is answer choice B, is not parallel. So that does it for this video, guys. I hope this video helps. This stuff is basically just what we were doing, just, in a little bit of a different context, okay? So what you need to do now, I've put some ungraded practice problems on the Google Classroom, and these problems are very similar to the ones that we just did for these 12, okay? If you have any questions, please let me know. There will be an answer key video for this posted in the future for you to look over and make sure that you understand what you're doing. Okay, please make sure that you watch those videos, and for now, I will see you in the next video, guys.